Hello everyone, welcome back. In this video, we are going to learn how metals and nonmetals react. So let's start the concept by observing electronic configurations of noble gases, metals and nonmetals. So let's start with noble gases. Helium, neon and argon. These are noble gases. Atomic number of helium is 2, atomic number of neon is 10 and atomic number of argon it's 18. So let's write the electronic configuration. So helium, since the atomic number is 2, its electronic configuration is also 2. Electronic configuration is arrangement of electrons in energy shells. So these energy shells we take to K, L, M and N. So this concept we have already done in class 9. These are different energy shells. In first shell, maximum 2 electrons can be accommodated. In second shell, maximum 8 electrons. In third shell also maximum 8 electrons can be accommodated, and here maximum 18 electrons. So this thing we have already done in class 9. So let's directly do the electronic configuration now. Atomic number of neon, it's 10. 10 means number of electrons in neon is 10. So 2 electrons will come in first shell, which is K. And in second shell, 8 electrons will come. 2 plus 8 is 10. So total 10 electrons are accommodated in this way. 2 in first shell and 8 in outermost shell, or outermost shell is also known as valence shell. So 8 electrons in valence shell in case of neon, and in case of helium 2 electrons in valence shell. Let's write the electronic configuration of argon. So number of electrons in argon is 18, as the atomic number is 18. So electronic configuration, it will be 2, 8, 8. 2 plus 8, 10. 10 plus 8, 18. So now if we observe, here also in outermost shell, 8 electrons are there. In case of neon, 8 electrons, and in case of helium, 2 electrons. So we can see outermost shells are completely filled. Since the outermost shells in case of noble gases, they are completely filled, due to which noble gases, they don't react, or we can say noble gases are least reactive. Noble gases, they don't react, they are least reactive and stable elements, as their outermost shells or valence shells are completely filled. Now we have seen electronic configuration of noble gases. Now let's move towards metals and write the electronic configuration of few metals. So first one, I'll take the example of magnesium. So 3 metals will take magnesium, sodium, magnesium and aluminium. So atomic number of sodium is 11. So 11 number of electrons are there, because atomic number is equal to number of protons and number of electrons. So 11 number of electrons are there. So let's write the electronic configuration. 2, 8, 2 electrons in first shell, 8 electrons in second shell, and because 11 electrons are there, 2 plus 8 is 10, and 1 electron in the outermost shell or valence shell. Magnesium, atomic number 12, which means number of electrons in magnesium is 12. So let's write the electronic configuration. 2, 8, 2. 2 plus 8, 10. 10 plus 2, 12. So 12 electrons are arranged in this way. Now in case of aluminium, atomic number of aluminium is 13, which means number of electrons in aluminium is 13. So it will be arranged as 2, 8, 3, because in second shell maximum of 8 electrons can be accommodated. So 2 plus 8 is 10, 10 plus 3 is 13. So we have written. So now if we see 1, 2 and 3. So in valence shell, in case of sodium, 1 electron is there. In case of magnesium, in valence shell, 2 electrons are there. And in case of aluminium, in valence shell, 3 electrons are there. So these valence shells are not completely filled, because each of the valence shells, it needs 8 electrons, but here we have 1, here 2 and here 3. So in order to attain noble gas configuration, we have already seen in noble gases, outermost shells, they were completely filled. So in order to attain noble gas configuration, or we can say in order to attain stability, sodium needs 8 electrons in the outermost shell, magnesium also needs 8 electrons in the outermost shells, and aluminium also needs 8 electrons. So here 1 electron is there. But if sodium, it loses 1 electron, now it has only 2 shells, and this is the outermost shell. So here in outermost shell, now 8 electrons are there. So it has attained noble gas configuration, or it has attained stability after losing 1 electron. Now magnesium, if it loses 2 electrons, now this is the outermost shell. So after losing 2 electrons, it has attained noble gas configuration. Same goes here also in case of aluminium. If aluminium loses 3 electrons, now this is the outermost shell, and in outermost shell 8 electrons are there. So it has also attained stability after losing 3 electrons. So this is how metals, they lose electrons to attain noble gas configuration. Now we have observed that metals, they tend to lose electrons in order to attain noble gas configuration. Now let us observe the electronic configuration of non-metals. There are so many non-metals. So let us take few examples. Nitrogen, oxygen and fluorine. So atomic number of nitrogen is 7. So atomic number is 7, which means number of electrons is also equal to 7. So let's write the electronic configuration. So in first shell 2 electrons are there, and in second shell 5 electrons are there. So 2 plus 5 is equals to 7. Atomic number of oxygen, it is 8, which means 8 number of electrons are there. So let's write the electronic configuration. 2, 6. 2 plus 6 is equals to 8. Fluorine, atomic number of fluorine is 9, which means number of electrons in fluorine is equal to 9. So let's write the electronic configuration. 2 and 7. 2 plus 7 is 9. So here, in order to attain noble gas configuration, we can see nitrogen, it needs 3 more electrons in valence shell or outermost shell. So 5 plus 3 is 8. And oxygen, it needs 2 more electrons. Fluorine, it needs 1 more electron in order to attain noble gas configuration. So here we can observe now that non-metals, they gain electrons in order to attain noble gas configuration. Nitrogen, it needs 3 more. Oxygen, it needs 2 more, and fluorine, it needs 1 more electron in order to attain noble gas configuration. Now let us study the compounds of metals and non-metals and see how the reaction is taking place. Let's take the example of sodium chloride now. Sodium, it's a metal, and chlorine is a non-metal. So let's write the electronic configuration, because we want to know the number of electrons in outermost shell or valence shell. So sodium electronic configuration is, because as the atomic number is 11, so its electronic configuration is 281, we have already discussed. And chlorine, its atomic number is 17, so its electronic configuration is 287. In case of chlorine, 7 electrons are there in valence shell, and in case of sodium, 1 electron is there in valence shell. From here you can also remember one thing: if number of electrons in outermost shell or valence shell is equal to 1, 2 or 3, that element will be metal. And if the number of electrons in valence shell is equal to 4, 5, 6 and 7, then that element will be non-metal. So if number of electrons is equal to 8, then it will be noble gas. So we have already discussed at the starting, in noble gases the number of electrons in the outermost shell is completely filled. So whether it's 8 or 18, so it will be noble gases when the outermost shell is completely filled. Now let's come back to the example. So we can see in sodium, 1 electron is there in outermost shell. So we can draw like this. Now in case of chlorine, 7 electrons are there in outermost shell. So let's differentiate. So we can represent with this cross. Now sodium, it has to gain 1 electron, and chlorine, sodium has to lose, whereas chlorine has to gain 1 electron in order to attain noble gas configuration. So sodium, it will lose its electron, and after losing it will acquire positive charge. After losing electron, sodium will acquire positive charge, and here chlorine, after gaining electron, it will acquire negative charge. Now you can see these are charged particles. We have already learned that in opposite charges, see this is positive charge and this is negative charge. In opposite charges, force of attraction is there, which is electrostatic force of attraction. Electrostatic force. Now positively charged sodium, it gets attracted to negatively charged chlorine. So due to this force, one bond is formed. So force itself is a bond. So that bond, it's known as electrovalent bond. Electrovalent bond. Why electrovalent bond? Because this bond is formed due to electrostatic force, and this is also known as ionic bond. Ionic bond. So why ionic bond? So again, since the bond is formed between two ions, ions are the charges, so that's why it is also known as ionic bond. And from here we can see metals and non-metals, they always react by transfer of electrons. By transfer of electrons, and they form ionic bond or electrovalent bond, and this is the strongest force. So that's why ionic compounds, see ionic compounds, they are very strong because they are attached to each other, or they are attracted to each other with electrovalent bond, which is one of the strongest force. So this, here you can see this give and take policy is taking place. This is giving its electron and this is taking its electron. So we can see overall the compound is neutral. Sodium chloride, it's a neutral compound, but in between it's positively charged and it is negatively charged. So in this way metals and non-metals react. They react by transfer of electrons. So we can take one more example we can take one similar example. We can say, let's take example of magnesium chloride now. So magnesium, atomic number 12 and its electronic configuration is 282. 2 electrons in outermost shell, so that's what we need. So 2 electrons, and I have already told you if number of electrons in outermost shell is 2, that element is a metal. So chlorine, in the previous compound also we have taken chlorine, it has 7 electrons in the outermost shell. Now magnesium, it has to lose 2 electrons, so it will lose 1 electron to this chlorine, and since 2 electrons are there, so we need 2 chlorine atoms, so it will lose one electron to this chlorine atom. So after losing this magnesium, it will acquire 2 positive charge. So why 2 positive charge? Because it has lost 2 electrons, and in case of chlorine it will acquire, because 2 atoms of chlorine are there, so directly here we can write 2, and after gaining electrons it will become negatively charged. Now again charges, this is positively charged, this is negatively charged atom. So force of attraction, that is electrostatic force of attraction between these two, between metal and non-metal, will take place, due to which they will form electrovalent compound, electrovalent bond or ionic bond. So this is metal. Again transfer of reaction has taken, transfer of electrons has taken place. So this is how metals and non-metals react. In order to attain stability or in order to attain noble gas configuration, metal they lose electrons and non-metals they gain electrons. So now let us understand the properties of electrovalent compounds or properties of ionic compounds. Let's do the properties of ionic compounds. First one is physical state. So physical state of organic compounds is solid state. See, if NaCl, it's ionic compound, this is positive charge and this is negative charge. So these charges, they attract with the strongest force, electrostatic force. So due to this force, these particles are closely packed. They are very close to each other like this. And we have already done in class 9 states of matter that when the particles are closely packed, they are in solid state, and when they are little far away, they are in liquid state, and when they are very far from each other like this, then the particles are in gaseous state. So since the particles of ionic compounds or the ions, these are closely packed due to the strongest force of attraction, this which is electrostatic force, these are solid in state. Then second is solubility. Ionic compounds, they are soluble in water. So you can just take the example of sodium chloride. Just try to dissolve it in water. You can easily dissolve sodium chloride in water. But these are insoluble in organic liquids. So organic liquids are like alcohol, kerosene, petrol, all these are organic liquids. So organic compounds are soluble in water and insoluble in organic liquids. Third one is conduction. So conduction, these charges are there, so they can easily conduct electricity, but the only thing is that they will conduct electricity only in aqueous state or in molten state. Aqueous state means whenever these are dissolved in water. So only in that case, because once we dissolve ionic compounds in water, the ions now they are free to move, and we know electricity is conducted only when charges are in motion. So now in aqueous solution, charges they will come to motion, due to which they will conduct electricity. And in molten state, molten means melted state, or when they are melted. So again, when they are in molten state, the charges they will be in motion, due to which they will be able to conduct electricity, but they won't conduct electricity in solid state, because in solid state charges are at rest. So once again, conduction of electricity is only possible in case of aqueous and molten state. It's not possible in solid state. because although they have charges in solid state, but the charges are at rest, they are not in motion in solid state. Now melting and boiling point. So boiling and melting points of ionic compounds are generally high because they are attracted to each other. Since we have, again let's take the example of sodium chloride now. Sodium, this is positive charge, this is negative charge. They are attracted to each other with electrostatic force of attraction, and this electrostatic force of attraction is the strongest force, and which makes a strong bond between sodium and chlorine. So in order to break that strong bond, more force or more energy is required. So a lot of energy, we can say, it's required to break this bond, due to which melting and boiling point of ionic compounds are generally high. Now we have discussed how ionic bond formation is taking place, and we have already done the properties also. Now let's do some textbook questions. The first question is, write electron dot structure of sodium, oxygen and magnesium. So sodium, its atomic number is 11, which means number of electrons is 11. So let's write the electronic configuration. It's 281. So number of electrons in outermost shell is 1. So electron dot structure of sodium is like this. Now oxygen. Oxygen, its atomic number is 8, which means its electronic configuration is 2, 6. 2 plus 6, 8. So its electron dot structure, because say 6 electrons are there in valence shell, so 6 dots we can draw. These dots, they are indicating electrons in outermost shell. Now magnesium. Magnesium, its atomic number is 12, and let's write the electronic configuration. It's 2, 8, 2. So number of electrons in outermost shell or valence shell is 2. So 2 dots we can draw. So from here, like I have already told you, its number of electron in outermost shell is 1, which means sodium is a metal. Oxygen, number of electrons in outermost shell is 6. So which indicates oxygen is a non-metal. Same goes here also, number of atoms in outermost shell is 2, which means magnesium is a metal. So this is just additional information. Now let's get back to the question, part second. So this was part 1, only we have to draw electron dot structures. So in part second, we have to show the formation of sodium oxide and magnesium oxide by transfer of electrons. So sodium, just now we have done, number of electrons in outermost shell is 1. So in oxygen number of electrons in outermost shell, it is 6. So now oxygen, it needs 2 more electrons. So we will take 2 atoms of sodium. So 1 electron is transferred from this sodium atom, and 1 it will get transferred from this. So this is how oxygen and sodium, both they will attain noble gas configuration. And sodium, since we are taking 2 atoms, so it will become N2. So charge, positive charge it will acquire, because it is transferring electrons or it is giving electrons. And oxygen, since it is receiving the electrons, so and 2 electrons it is receiving, so 2 negative charge it will acquire. So we can see, now we can also write it as Na2O. Here plus charge and minus 2. So here it's not required because we have already written here. So this is the formation of sodium oxide. Now let's do the formation of magnesium oxide. We just have to do the transfer of electrons as per the requirement. So magnesium, number of electrons in outermost shell, we have already done, it's 2, and in case of oxygen, number of electrons in outermost shell, it is 6. So 2 electrons magnesium will transfer to oxygen. So magnesium, since it is giving 2 electrons, so it will acquire 2 plus charge. So how many electrons a particular atom is giving, that charge it will acquire. So it is giving 2 electrons, that's why 2 positive charge. See, in the previous case, why only 1 positive charge was there? Because 2 atoms of sodium we have written in this way, but each atom it was giving only 1 electron, that's why the charge was +1, not +2. Now this single atom it's giving 2 electrons, that's why it will acquire 2 positive charge, and oxygen, since it is receiving 2 electrons, so it will acquire 2 minus charge. So we can get ionic compound magnesium oxide. So the third one is, what are the ions present in these compounds? So in the previous one, in sodium oxide, the ions were Na2, so this charge was there, then O2 negative. So and 2 atoms of sodium it acquired 1 positive charge, and oxygen 2 negative charge. So these ions were in case of sodium oxide, and in case of magnesium oxide, ions are Mg2 positive and O2 negative. So here we can also write as Na positive, because one atom we can write, so Na positive to O2 negative, and Mg2 positive and O2 negative. These are the ions present in these compounds. Now let's do the next question. So second question is, why do ionic compounds have high melting points? So we have already discussed this thing, that ionic compounds, they form bond by electrostatic force of attraction. So we can mention it requires a lot of heat energy, because heat is required for melting. So heat energy, we can mention lot of heat energy to break electrostatic force of attraction. So due to which melting point of ionic compounds is high. See, this is Na positive, and this is the electrostatic force between Na positive and Cl negative, these two ions. So if you want to break this force, then a lot of heat energy is required, due to which ionic compounds, they have high melting point. So this is all about how metals and non-metals react. In the next video, I will continue with the extraction of metals. So if you like the video, do share, do subscribe. Thank you so much for watching the video.